Hello and welcome. In this video, we'll be going through the Godot documentation's Your First 3D Game. Let's get started. The first thing you're going to need to do is go all the way down to the bottom of your first 3D game page and click on Squash the Creeps Assets. Make sure you download that. You can also find the same link here on the next page under Setting Up the Game Area. Unlike with the 2D project from the documentation, the 3D project is not only the assets, but also the project file. So what you're going to do is you're going to go ahead and extract this and put it wherever you need it to be. Then you're going to boot up Godot. You're going to click on Import Existing Project, and you can go ahead and click here and double click on that project file. You'll click on import, is all fine. This is just converting it to the newest version. Hit OK. Now we're in. Before we go any further from here, I do just want to give a little heads up that I won't be explaining anything that we've already seen before in the documentation. I'll only be giving extra explanation for new concepts that pop. With that said, let's get started with setting up our playable area. And we'll start that by setting up our main scene. So you're going to click on Other Node, and then just a plain node is fine. And hit F2 immediately. We're going to call this Main. Then we'll hit Control S to save it. I'm just going to put everything in the root directory. This isn't a very complicated project, so I think it's fine to just dump everything in one place, but don't do this for your own projects. The first thing we're going to need is a static body 2D. So I'm going to select the main node, hit Control A, and then let's go with a static body 3D. Now then, if you hover over this node configuration warning, it will tell you it doesn't have a shape, so it can't collide, so we need to give it some collision. Select it, Control A, and then type in collision shape 3D, enter. While we have it like this, let's go ahead and rename static body 3D to ground. Now then you'll notice we have once again been giving a warning. Shape must be provided, obviously, because the collision shape 3D needs a collision shape. You want to do that, make sure you have it selected. And then in the inspector on the right, let's go to a shape. And we're going to give it a box shape 3D. Seems appropriate. Select it and it'll look just like this. Now, while we can adjust the shape by left clicking on these little orbs and dragging it, I'm going to give you the exact numbers that we need. In order to edit them directly though, go ahead and click on the box shape 3D resource right here and type this in. Use 60 on the x-axis, 2 on the y, and then 60 on the z. It'll be like that. Zoom out a little bit so you can see it. So collision shapes are invisible. We need to give it something visible so we can see it. So we're going to select the ground node and let's go ahead and give it a mesh instance 3D, just like that. Obviously we don't have a mesh, so let's give it a mesh. Go over to the right and from here, select this down arrow and go ahead and click on box mesh right here. You're going to click on that box mesh resource just like we did for the collision shape. And you're going to type in this 60 by 2 by 60. Now we have a visible mesh as well as a collision shape 3D for it. Now there's two ways we can do this. You can select ground and then hit Y on the keyboard to enable snapping. And with that, if we just click and drag on this yellow, we just click and drag on this green arrow, we can move it down by a meter. Now you can see the floor grid as well. Alternatively, if you don't want to have to remember to use that, or if you left click and then you hold down on control, you will also move it with snapping. Just check and make sure it's 1 meter, and that is, -1 is right below. So it's right where we want it. Now let's add a little light to our scene. We're going to select the main node, Control A, and then add a directional light 3D. It's like that. It's going to look a little weird, but that's okay. Let's fix this up now. So let's enable a shadow, and then what you're going to do is raise the light up, and then rotate it until we get some light on our ground. It's very bright. Let's just do it like that for now. Actually, that is too dark. So let's keep going. There seems good. All right, let's set up this player scene. Hit Control N to make a new scene. And from here, we're going to go to Other Node and start typing in Character Body 3D. A 3D physics body specialized for characters moved by script. That's important because this isn't automatically moved by the physics engine. Hit Create. And because it's important to be organized, let's immediately rename this to Player. Next, let's go ahead and save this. I'm going to hit Control S and we'll just put it right here. Although best practice is to have a separate folder for your player assets and things like that. It's going to call it Player. I'm going to hit Save. Now it's a really good practice to separate the mesh of a character from the collision of the character. So we're going to do that here and I'll show you. It might be a little confusing at first, but don't worry. I'm going to select the root player node here, hit Control A. We're just going to pop in a blank node 3D right here. Hit Create. Let's rename this to Pivot. Then go into the art folder of the assets that you downloaded. And where it says player.jlb, we're just going to left click and hold on that, drag it over and onto Pivot. This is a pre-made scene, as you can go into here. I'm just going to open it anyways. We're not going to stick in this. And you'll see what it is. It's basically just the mesh for the player. I'm going to close out of that. And we're going to actually rename this to be Character. You'll see we do still have the warning because we have no collision shape. So let's go ahead and add that. With the root node selected, go ahead and hit Control A, and then we'll just type in collision shape 3D right there. enter. Now the warning is gone, but we have a new one. We need to give it a shape. So with that selected, we're going to go over to the shape resource on the right and go ahead and give it a new sphere shape 3D. You may not see anything at first, but it is there, as we can see by this little orb, this little circle. I'm going to set it to 0.8. Or you can set it manually. It's still a little small, but that should be good. Now we want to make it so that the bottom of our collision shape intersects with the bottom of our grid. So to do that, if you want to make it a little bit easier, you can just hide the character model and take this little green arrow. I'm going to hold control down so it snaps. And that's a little too high. So let's just align it like this. It's like that. And that should be okay. A better way to do it, if you don't want to do it by perspective, you can left click on this and then go to switch perspective orthogonal view. That way we eliminate perspective. And then you can just left click on this for right orthogonal. And then from here, you can exactly align it like so. That's one way to do it. Let's go ahead and bring back our character model. Now we're going to set up our player input. You can do that by going to project settings. And then from here, go ahead and click on the input map tab. In the input map, if you want to see the default actions, you can just left click on show built-in actions, but we'll be defining our own. Now we need to define the move left, move right, move forward, move back, and jump actions. So let me just go ahead and take care of that right now. You do this by left clicking where it says add new action and then just typing it in like so. Move left and hit enter, right, and so on. When you're done, you should have these 5 actions. If you want to bind an action, you're going to left click on the action itself and hit the plus sign. It's going to listen for input. For move left, I'm going to use the left arrow key. And I'm going to hit OK. I'm going to do the same for the rest of these. And then for the jump action, we're going to use the space bar. In addition to this, go ahead and bind your keyboard's letter keys to this. It should be WASD. Finally, let's go ahead and add joystick support. So for move left, we're going to do it manually this time, but I'll show you how to do it automatically. Go on add event for move left. Then we're going to go under joypad axes. And then we're looking for joypad axis 0, left stick, joystick 0 left. Left click on that, hit OK. For move right, we're going to do a similar thing. We're going to go here, joypad axes, and we're looking for joypad axis 0 positive. Left stick right, joystick 0 right. Go ahead with that. Move forward will be joypad axis 1, left stick up, joypad axis 1 negative, left stick up, joystick 0 up for all devices. Move back will be joypad axis 1 positive. That one, joypad axis 1 positive, and then hit OK. And then jump, we're going to go to joypad buttons, and it should be joypad button 0. Bottom action, Sony Cross, Xbox A, Nintendo B, and hit OK. I'm going to confirm that that's correct because I have a little controller right here. So let's see if it works that way. I'm going to go ahead and just delete this one, and we'll hit the plus sign. And with my controller, I'm just going to go ahead and hit the A button to work. There you go. You could have also done the same thing with the other axes on the controller. Now let's get our player movements set up. So in order to do that, we do need a script. We're going to go to our root node for the player, right click, and then click on attach script. I have a little shortcut set up because I do this often. Mine's Control-Shift-Q. Now for this, we're actually not going to use the built-in template. We're just going to use the object empty template. It's not a built-in script and the path is fine for this project. I'm going to click on create. So this extends character body 3D just means that this class, this player class that we've created, has all of these properties and methods. It inherits all of these properties and methods from character body 3D. So I can use all of these in my player.gd script. But that won't be enough for us to get player movement going, so we do need to define some of our own. We're going to start off by defining some basic things that we're going to need, such as speed. And what this is how fast the player moves in meters per second. This export allows us to modify this value, which we've defined here with the var keyword, through the editor. Let's do another one. The downward acceleration when in the air in meters per second. So again, we're going to use the export var fall acceleration is equal to 75. Var target velocity is equal to vector3 dot 0. Now then, a vector 3 is just like a vector 2, but with an extra value, with 3 elements instead of 2. Now, a vector 3 is not the same thing as a 3D coordinate, although it has an X, Y, and Z value. A vector 3 is actually a direction and a magnitude. Now, this vector 3 in particular is set to 0, which means X, Y, and Z are set to 0. Now, if we hover over this and hit Control Space, we can see some other directions. For example, what is left? What does vector 3.left mean? We hover over that, it says it right there. This represents the local direction of left and the global direction of west. So by that logic, vector 3.forward should be north. This represents the local direction of forward and the global direction of north. And notice here the vector 3 is 0 on the x, 0 on the y, but -1. Let's change this back to 0. Now let's code the actual movement using the inputs that we defined earlier. So I'm going to go ahead and just type this all out, and then I'll try to explain it once I'm done. So we're going to define a new function here. FUNC, physics process. This is a built-in method. From here, we create a local variable to store the input direction. That will be bar direction is equal to vector3.0. Next, we check for each movement input and update the direction. If the input.isActionPress, I'm just going to type it all out and then hit enter. I don't like doing underscores, they slow me down. Let's do move, actually hit control space and go down to move right, so I don't have to type it in. Semicolon, direction.x is plus or equal to 1. Now I'm going to go ahead and type out the rest, and then I'll show you what it looks like when I'm done. So after typing out everything, this is what your movement should look like too. So you may want to pause and catch up here. This should look pretty familiar to you if you did the 2D project before. However, unlike in the 2D project, we're not doing our input in the regular process method. We're doing it in the physics process method. And this is a special method called by the Godot engine where you should be handling all of your physics things like movement. Within here, we'll be defining a direction, and we're setting that to a vector 3.0 because there shouldn't be a direction at the start, and we shouldn't be moving at all if we're not pressing any buttons. So then we're using 4 different if statements to check and see if the player is pressing any of the buttons that we've defined way back over here in project settings and the input map. So we've already defined all these movements. We haven't set the jump yet. If the player is pressing any of those keys, then through the magic of vector math, we're going to change the direction. We're going to change what's within this vector 3.0, and the vector math will handle our movement for us. And then the isActionPress method is obviously checking for this input that we're passing through to it. And then our direction.x is handling our movement to the right and the left. Notice z is what's handling our forward and back because z is our depth. The y-axis would be handling our elevation going up and down. Now then, as for the physics process, if you hover over it, you can think of this as a way to consistently measure time in between the physics ticks, and it ticks in delta, which I also explained in the previous video on the 2D project. It doesn't return anything, so that's why this says void. So let's go down here, stay within the function. If the direction is not equal to vector 3.0. What this line means is if we are moving, because if we're not at 0, it means we're moving, then the direction is equal to direction.normalized. A little note here. Setting the basis property will affect the rotation of the node. Let's take a reference to our pivot. Basis is equal to the basis looking at direction. So let me explain this. As I said before, this just checks to make sure that we are actually moving so it's not running this code constantly. It doesn't really make sense to do that. Now that we need to set our direction to be normalized. This little function is what handles normalizing the value. And the normalized value is between 0 and 1 usually. Now then this line right here, this $sign denotes that we're getting a reference to this node right here. That node needs to be within the tree underneath the player. And now a basis, we can think of that like, well, this is kind of a basis. This isn't the same thing, I'm oversimplifying. So the basis here, we can see that y points up. With all 3 of these together, we've established a basis for the orientation of this object. Without this, it makes doing vector math even more difficult because we do need some way of establishing and maintaining the orientation of this object, and that's the basis. Now that we're back in the script, we do need to do a couple more things. Namely, we have to calculate the ground velocity and the fall speed separately. So this is where we're going to define our ground velocity. Target velocity .x is equal to direction .x times speed. And the next line's almost the same, so I'm just going to hit Control, Shift, and D to duplicate the line down. Instead of the x-axis, we'll be targeting the z-axis. Now what about our vertical velocity? If not is on floor, there we go. This checks that we are in the air, then target velocity .y. So it's the first time that we're adjusting our y value in our target velocity. Target velocity .y minus fall acceleration times delta. And now we need to actually move the character. Velocity is equal to target velocity, and then move and slide. This is basically just giving us the normalized speed as we move around on the ground. Now the vertical velocity is using this method is on floor, and we're getting that from the character body 3D class. Now then, if we're not is on floor, because is on floor returns true if you're touching the floor, then that means we're in the air, and so our Y velocity needs to start being affected by the fall acceleration times delta, and the fall acceleration would be something like gravity. With all of that, we can now establish moving the character, take that target velocity that we've been working on, apply it to our actual velocity, and then move and slide is another method that we're getting from character body 3D, and this is what basically sets it all in motion. So we're going to have to instantiate our player scene into our main scene. So let's instantiate this. I'm going to click on my root node, the main node, right click on that, and then you can click on instantiate child scene. I'll click it for now. Let's take this player.t scene, and there we go. There's our little alien. If you want to center on it, you can left click on that and just hit F within the viewport, and you can also double click on it like that. If you double click on the text itself though, you'll try to rename it, so don't do that. If you were going to try to run this scene as it is right now with F6, you will see nothing because we don't have a camera. So let's set that up. Now, first thing I'm going to do is I'm actually going to go ahead and collapse this ground tree because I don't want to see it right now. And then we're going to right click on the main node. We're going to add a child node. And for this one, we'll be using a marker 3D, just like that. Hit create. We're going to name this camera pivot. And to this camera pivot, we will be adding the camera, and we need a camera 3D. So make sure that your scene tree looks just like mine, with the camera pivot being a child of the main node, not the player node. From here, we need to position the camera. So to do that, make sure you left click on the camera 3D, and you'll see this preview pop up in the top left of your viewport. You can go ahead and use that. So let's left click into that. This isn't very useful, so let's make it a little bit more usable. Go ahead and click up here where it says view, and we're going to use the 2 viewports. So click that. This is a lot easier to manage, isn't it? Alternatively, if you see here, we actually have some hotkeys right here. We could have hit Control 2. And I'm actually going to flip this around. So I'm going to uncheck that, and I'm going to check it here so that the bottom one is the camera view and the top one is my view. In the top view, let's click on the camera 3D directly, and then I'm going to go down to its transform right there. From here, the documentation wants us to move the camera 19 units on the Z-axis. So I'm just going to left click on this. I'm going to watch that transform up down there. Hold down Control. I'm going to move it 19 units away. Just like that. As you can see, it says 19 here on the Z-axis. Next, we're going to actually use the camera pivot, not the camera 3D. So you left click on the camera pivot, and we're going to rotate this -45 degrees around the X-axis. So let's go ahead and follow those directions. Let's move it -45. I don't like that, so I'm just going to type in. As you can see here, we didn't rotate the camera 3D by -45 degrees. Otherwise, we would just be pointing down and would be at the wrong angle. All we did was we took this camera pivot and we rotated that instead. You can kind of see how it works up here in the top viewport. How as we rotate it, it's pointing at something and it's rotating around that or orbiting around that. But before we run this scene, go ahead and go to camera 3D, and then on the right hand side in the right dock, next to where it says projection, we're going to change that from perspective to orthogonal to remove the perspective from the camera. In addition to that, we need to set the size to 19, otherwise it's too close. With that done, we should be able to actually run this scene. So I'm just going to go ahead and hit F5. I haven't defined a main scene yet, but I'd like to use this one as my current one. So I'm going to hit select current. Now, if we use our keys, our character will move around. And indeed, I can move my character with my controller. This view is a little annoying, so I'm going to actually go back to my regular one viewport. Hopefully the camera rig makes sense to you. If not, I can kind of illustrate with this. So the point of this pen, you can think of that as the point where the camera pivot lives. It's the 0, for the camera pivot for the marker. And then the end of the pen can be where the camera itself is. Now the camera's position, we've changed it, but it always maintains its position relative to its parent, which would be the point. So as the parent rotates, let's say it rotates forward, -45, this is what's happening. So I'm moving like that. The camera's maintaining its position relative to its parent. So it's still maintaining that distance of 19 on the Z away from its parent. So no matter what, it's doing that. That's why it rotates like on a crane. Hopefully that made sense. Now let's go ahead and create our enemy scene. We'll be calling it the mob scene from now on. I'm going to hit Control N, create a new scene, and we're going to use a character body 3D as its root node. As soon as you get it in there, go ahead and rename it to mob. And similarly to our player scene, we're going to go ahead and give it a rig. And for that, we're going to use a node 3D, and we're going to name that pivot. I hit F2 as soon as I made it in order to rename it immediately. For this one, we'll be going into our file browser and look for mob.glb. Left click and drag that right on over to the pivot to add the model to the scene. Let's go ahead and rename this one to character. With mob selected, make sure mob is selected, not the pivot. I'm gonna hit Control A and collision shape 3D. Hit create. Over here, the shape we're gonna give it is a box shape 3D. Click on that and open that up, but it doesn't help too much. And from here, I'm going to left click on this positive Y so I can see it from the top. From here, what we're going to do is we're just going to click on these little orbs and drag it to about the base here. And from here, let's go up to the top. We could probably use a little bit more here. So let's just cover right over the eye. And we don't need it to be going into the ground like that. That should be about right. I'm going to stretch this out just to the center, making sure it covers the eyeballs. And I think that'll be fine for now. I'm going to raise this a little bit. On second thought, I don't really mind if this model digs into the ground a little bit. So let's just put it right there. That should be fine. So what we're about to do is set up a way for when the mob leaves the screen, we'll delete it. There's a couple of ways to do this. Documentation is going to have us do it in kind of a simple way. So we'll just cover this for right now. What we're going to do is select the root node for the mob, and we're going to add a child node called visible on-screen notifier 3D. So not the visible on-screen enabler, make sure it is the notifier. Now we can use these little circles to once again cover the 3D model itself. That should be fine. So when the entirety of this box leaves the screen, it's going to emit a signal. As you can see here, it can emit the screen entered signal or the screen exited signal. We'll be using that later. Let's go back to the inspector. Now we're going to set up the mob's movement. So let's left click on the root node, right click, and then go to attach script. We're just going to use the object empty template, then hit create, and it'll bring us to the script editor. Once again, I'm just going to type everything out and then I'll explain it afterwards. This will be the minimum speed of the mob in meters per second. It's going to be an export variable. The minimum speed is equal to 10. Here's the maximum speed of the mob in meters per second. Export variable, max speed is equal to 18. For this, we'll use the physics process _ physics process, and I'll hit enter. And then we'll just start off with move and slide. Now then we're going to define a new function. This function will be called from the main scene. Notice it says this function will be called from the main scene, but it does not live in the main scene. It lives within this mob.gd script file. That'll be important coming up. Func initialize. It's going to take in a parameter of a start position and a player position. We position the mob by placing it at start position. Should be kind of clear. Another comment, and rotate it towards player _ position. So it looks at the player. Here we go with look at from position. This is a built-in method. It takes in that start position as well as the player position, and then it needs a direction. So we're going to go vector3.up. This direction is really just defining what is up for the mob. Rotate this mob randomly within a range of -45 and +45 degrees, so that it doesn't move directly towards the player. Rotate Y, random float, rand f _ range. This also takes in -pi divided by 4, I divided by 4. Hopefully these make sense to you, but basically this function we've just written initializes the enemy. It takes in the start position for this enemy, as well as the player position, wherever the player is when it spawns. And then it uses this built-in function called look at from position. This also takes in its start position and the player position and what direction is up so it can orient itself. And this rotate Y will just orient the enemy towards the player. The -pi divided by 4 will come out to be -45 degrees. Now then we need a little bit more. So we also need to calculate a random speed in the form of an integer. Bar random _ speed is equal to randi _ range. Obviously it stands for random integer within the range of min speed and max speed. We define these at the top here, as you can see. We calculate a forward velocity that represents the speed. Velocity is equal to vector3.forward times random speed. Then from here, we then rotate the velocity vector based on the mob's Y rotation in order to move in the direction the mob is looking. Now then, velocity is now equal to velocity dot rotated vector3.up rotation Y. think this is explained pretty well in the comments. The only thing that might confuse you, I imagine, is that vector3.up and then rotation.y is here. If we hover over this method, it shows the first parameter is the axis and the second one is the angle. So the vector3.up does not mean we are rotating up. It means that within this 3D space, we'll be using the y-axis to rotate. So if we rotate something on the y-axis, it actually turns left and right. And then this second rotation.y, all that does is make sure that our velocity is matching up with the rotation of the mob. Because it's one thing to be rotated and it's another thing to be moving in the direction of that rotation. Now we need to get rid of this mob once it leaves the screen. So let's go back into the 3D viewport, then select the visible on-screen notifier. We'll go to node, double click on the screen exited signal, and then we will just connect this to the mob script like so. Don't have to do anything special. Click on connect, and it's gonna make this method for us. And then quite simply, all we do here is we type in q_free and then hit enter. So as soon as this mob leaves the screen, it will run the queue_free method and delete it. So as soon as the mob leaves the screen, this will delete it. Now, if signals don't make sense to you, I did cover them in more depth back in the 2D project, as well as in the documentation in the getting started section. But I will also be covering them in even more depth when we get to them in the manual. Now it's time to get these mobs spawning in. So let's go back to our main scene. And first thing we need to take care of actually is go up to project settings. We need to change the resolution of our game. I'm going to go to display, window, and for viewport width, let's go ahead and change it to 720. And for a height, let's change it to 540 and hit close. To find our viewport's width, we're actually going to use placeholder meshes. And to do that, I'm actually going to have to open the viewport back up to 2 views. I hit Control 2. I'm going to left click on the main root node, hit Control A, and then we're just going to type in node 3D. I could have clicked it right there. I hit create, and we're going to rename this one to cylinders. This is just going to be like a little group for our cylinders. Then with cylinders selected, hit Control A and type in mesh instance 3D. Make sure your mesh instance 3D is selected and then go to the inspector. Go over to where it says mesh under mesh instance 3D, and we're going to give it a cylinder mesh, just like that. And then so we can line this up a little easier, I'm going to click on this top left option where it says perspective. And we're going to switch to a top view. It's like that. Now, I don't really mind having the grid here, but if you want to get rid of it, you can left click right over here and then you can uncheck view grid. But I'm going to leave mine on. Let's go ahead and enable snapping. I'm going to hit Y on my keyboard. There are 2 easy ways that you can move this cylinder around. You can either just mess with the transform position over here on the right, or if you hit W on your keyboard, you'll enable the move tool. And we can use this little green square. Just move it just barely out of sight. That is, of course, too far for this. So let's go ahead and move it back until we can see it in the top viewport, but not in the bottom one. So that should be fine. I like it better in this position. So it's going to be at -12 on the x-axis and -14 on the z-axis. So with this top left node in place, I'm going to make sure it's selected. I'm going to hit Control D. Using this blue arrow, I'm going to move it down until it disappears from my sight. The bottom viewport right there. Let's select both of these. What I'm doing is I'm left click on the top one and holding shift and then left clicking on the bottom one to select everything. From here, hit Control D to duplicate both of them at the same time. And then I'll use this arrow to move them over to the right. I'm going to zoom out just a little bit, and then I'm going to check to make sure that they are in the right place. And that should put them right where they need to be. Now these are pretty hard to see, so let's go ahead and change their color. Using the same technique, let's select the top one, hold down shift, left click on the bottom one in the list, and now we'll select all 4. And we're going to click on this mesh resource. So left click on it like that, and that'll show us all the properties of the mesh resource. If you look closely, you'll see that right over here it says material, and we need to give it a material if we want to change its color. So go ahead and click on this little arrow. We're going to give it a standard material 3D. Now it has a material resource. Now left click on that, I'll scroll down so you can see. What we're looking for is the albedo section. Under here, go ahead and click on where it says color. And then let's use a nice bright orange, F78B00 on hex. There you go. Now it's very easy to see them. And let's go ahead and collapse this cylinder node. I just clicked on this little arrow right there. So just like in our 2D project, we need to make a path where we'll start spawning our monsters from. So go ahead and left click on the main root node. Then we're going to add a path 3D this time. Hit create. When you have the path 3D node selected, you should see these tools pop up in your viewport. We're going to use this add point tool and just click on the center of each point. Let's go clockwise for this, just like that. And then when you have the fourth one, go ahead and click on close curve. Now, although it's set to black right now, it's pretty hard to see. If you come to custom color, you can actually change this over to red, and you can see that it does in fact match up with the shape it should be. Set that back. Now, if we want to actually get points on this path, we need to make a path follow 3D. You can click on this right here, or you can type in path follow 3D, hit enter. Now let's rename the original root node of this to spawn path and then spawn location. We always use Pascal case for node names. Now let's go back to our root node, our main node, and then add a script. We're just going to use these same settings here. Click on create. So we do an @export var mob scene is a packed scene. Over here on the right, you'll see, because we did this export, that we can now assign a custom resource of a mob scene. We're going to click on this arrow, go to quick load, and then where it says mob.tscn, we're going to select that. Don't select the GLB file because it will not work. With main selected, I'm going to hit Control A, and we're going to need a timer now. Hit create and rename this to mob timer. We use Pascal case. Let's look over to the right side of the screen. We're going to change the wait time to 0.5 seconds and set auto start to on. Now then, making sure that you have the mob timer selected, I've adjusted my UI a little bit. You're probably going to see a node tab over here. But if you don't see a node tab, what we're trying to get to is the signals tab. So I'm just going to click on my signals tab here. And then we're going to double click on the timeout signal, and we are going to attach it to our main node using this receiver method name. Now then, as for the documentation, what we're about to do is we're going to instantiate the mob scene, sample a random position on the spawn path, get the player's position, call the mob's initialize method, passing it the random position and the player's position, and then we're going to add the mob as a child of the main node. And we will be doing it within this receiver method that was created for. I'll highlight this and comment here, create a new instance of the mob scene. Var mob is equal to mob underscore scene dot instantiate. Enter there. I'm going to type this all out and then I'll go back and explain it to you. Choose a random location on the spawn path. Then we store the reference to the spawn location node. Var mob underscore spawn underscore location is equal to get node. And we're going to use a string here. Spawn path / spawn location. And give it a random offset. Mob underscore spawn location dot progress underscore ratio is equal to rand f. Then var player underscore position is equal to $ player dot position mob dot initialize mob underscore spawn underscore location dot position comma player underscore position. Then for the last comment, spawn the mob by adding it to the main scene. Add child mob. So what's happening here is when the timer times out, it's going to run this method here. This line here is just taking this mob scene that we assigned earlier and instantiating it. As the comment states for this one, on this line, we are storing a reference to this spawn location node that we made earlier right here. The randf method is returning a random floating point number that is between 0 and 1. With that number, it's assigning it to the progress ratio for the mob spawn location. If we go ahead and look over at spawn location in the inspector, you'll see it has this progress ratio, which goes from 0 to 1 along the path. And so that's how it's being used. Here, we're getting a reference to the player node, and we're taking its position, which right now is defaulted to in the center, and assigning it to the player position variable. Now, with both of these values, we can now assign the location that the mob will spawn. So here's the mob spawn location, which is along that spawn location path, and then we have the player's position. This is being passed into the method that we made in the mob script earlier, this initialize one. And after all that's done, we're going to actually add the mob into the scene by adding it as a child. This will make it a child of the main node while it's running. And with that, if we hit F5 now, the game will run and we can move around. We don't die or anything. See, we can stop the mobs and they will run into each other. Stop that with F8. Now we're going to get ready to implement the jumping and squashing mechanics. But first, let's do a little bit of cleaning up. So we're going to go to project settings, and we're going to scroll all the way down to where it says layer names right here. Specifically, we need to be in 3D physics layer. For our layers, we're going to name them player, enemies, and world. And that's all we have to do here. Hit close. Then on the left, underneath our main root node, click on the ground node that we made in the beginning. Look over underneath collision object 3D, and we're going to click collision. So if you look over to the right, you'll see the collision section. Now, the way I've always understood layers is that under this layer section, this is where you want the node to exist. And for the mask, this is what you want the node to interact with. So because this ground is not the player, we're not going to keep it on the player layer. We're going to set it to the third one, which is the world layer. Now, we don't actually need the ground to care about the player. The player can care about the ground, but the ground doesn't care about the player. So we're going to uncheck player, and that's it. We don't need it to really care about any of these layers. The only thing it's going to do is prevent the creatures and our player from falling through it. Now let's fix the player one. So we're going to select player and then go back here under collision object 3D, just like we did before. Click on collision. Now we do want this to live on the player layer. That is where it exists. That's what it is, but it doesn't need to care about itself. We're going to uncheck player. It does need to worry about enemies, and it does need to care about where the ground is or the world environment. And now let's fix the mob scene. To do that, we're going to go into the mob scene like this. You could also hit Control-Shift-O and select mob.tcn. Now with the mob selected, we're going to do the same thing. Look over to collision object 3D, select collision. Now this is an enemy, so it needs to live on the enemy layer. It's not a player. For the mask, we're actually going to uncheck the player layer. The player needs to worry about collision with the enemies, but the enemies don't really need to worry about collision with the player. We don't need the ground layer or the world layer masked because the mobs don't need to mask the world layer. They only move on the XZ plane, so we don't apply any gravity to them by design. Now we can finally implement jumping. So what I'm going to do is we need to open the player script. You can hit Control-Alt-O, type in player. This is a quick way to open scripts. Alternatively, if you had the script tab open, you just click on it like that. Right underneath our fall acceleration variable, we're going to add another one. Type in export var jump impulse is equal to 20. This will be the initial force of our jump. And then scroll down to our physics process method. Right before our move and slide method, I'm going to put my cursor right here and hit Control Enter to go right in between. And we're going to type in our new if statement. If is on floor like that, and input dot is action just pressed jump, and then a semicolon, target underscore velocity dot y is equal to jump underscore impulse. So what this if statement is saying is basically if is on floor returns true, and if input action just press is jump or our space bar, as long as both of these are true, so we're on the floor and we're pressing the space bar, then to our target velocity in the y axis, go ahead and make that the jump impulse. So in addition to that, we defined our vertical velocity back here, and this is what sort of simulates the gravity that you can see. So if we hit F5 now, go into our game and we press space bar, sure enough, we have a little jump. And we can jump on top of them if we want to. They took me away. There we go. Goodbye. And hit F8 to cancel that. Now, because we don't want to ride our enemies when we jump on top of them, we want to destroy them, we're going to have to implement them. So I already have the mob scene open, but if you didn't, hit Control-Shift-O and mob TSCN. Make sure you have the mob node selected like that. It'll show up like this in the inspector. You'll have a node tab that you can click most likely. So click on your node tab, and under that, we're looking for groups. So click on groups. Go ahead and click on the plus sign, and under name, type in mob. This isn't going to be a global group, so go ahead and hit OK. We can confirm that our mob is in the group because if you look into the left dock right here, it says node is in this group mob. And this square with a little circle over it denotes that it is in a group. Look back into the player script. At the very top, underneath jump impulse, go ahead and type in @export var bounce underscore impulse equal to 16. We're going to go back down to where we implemented the jumping mechanic over here, and we're going to be doing this with a for loop. Make a little bit of space. It's going to be quite a bit of typing, so hang in there. For index in range, again, I will explain all of this when I'm done typing. Get slide collision count. What's that one? Is that a semicolon? Var collision is equal to get underscore slide collision. Hit enter. We're going to pass in index here. Hit enter, little space. If collision dot get collider is equal to null, continue, and hit enter. Let's align this with the other if statement. If collision dot get collider dot is in group, gotta type that one out, is in group mob var mob is equal to collision dot get collider. Next if statement. This if statement will need to be within the previous if statement. If vector 3 dot up dot dot type that out. Collision dot get underscore normal is greater than 0.1 mob dot squash target underscore velocity dot y is equal to bounce underscore impulse and then break. And then I'm going to give myself a little more room. We're not quite done here. We do need to add something to the mob script. You may have noticed we have this dot squash. This is an undefined method, so we need to go define it. So let's open up the mob.gd script and let's define this new signal. So underneath extends, go ahead and type in signal squashed. And then let's make the function. So underneath this one, type in func squash, parentheses, semicolon, enter. Squashed dot emit, so we can emit that signal, and then queue free. This basically causes the mob to emit the squash signal when it's squashed and then delete itself. Let's go back to the player script so I can explain this to you. Some of the things we're doing here is just to check for different cases to prevent crashes and prevent interacting with things that don't exist. For example, this get slide collision count and this whole for loop we have right here. So what this for loop is doing is it's checking for how many times the player has collided with something. We'll go through all the collisions per frame that are occurring during this move and slide method. And for each of them, going to basically assign it to an index. And whatever's in that index is considered a collision. So now this section here, if collision.getCollider is equal to null, continue. What continue here does is it immediately ends the current iteration, skipping any remaining statements in the loop body for that iteration, and then moves on to the next iteration. And this is an important distinction to make from break. So what break does is we leave all this for loop in its entirety, but continue doesn't do that. What continue does, it allows us to go on to the next section. Now the last section here, if collision.getCollider is in group mob, this is checking to make sure that what we are colliding with is in the mob group. Then we take whatever we collided with and we're going to assign it to the variable mob. Now this whole section here is the vector dot product. Now with dot products, when the result here is greater than 0, then it means that the two vectors are at an angle of fewer than 90 degrees. A value higher than 0.1 tells us that we are roughly above the mob. So this whole line is here just to make sure that we are landing on top of the enemy, roughly like this. And if we are landing on top of the enemy, let's call it squash method, which we defined right over here. After we've called that, the mob will die and then we'll bounce. So immediately our Y velocity gets the bounce impulse, which causes us to kind of bounce off. And we can check that by running the game with F5. As you can see, I'm just gonna bounce, maybe get a double kill. Let's go ahead and close this with F8. All right, now for the best part, we need to find a way to kill the player. So let's open up our player scene again. If you didn't have it open, you can just go ahead and type in Control-Shift-O. I really like this shortcut, player.tscn. Make sure to have the player selected and add a new child node. We're gonna make it an area 3D. Hit create. Name this one mob detector, enter. And to this one, hit Control A, and we're gonna add a collision shape 3D to that one. With this collision shape 3D still selected, go to the inspector and we're going to give it a new shape. Click on this arrow, and for the shape, we're going to use a cylinder shape 3D. The collision shape 3D added and its shape given to it. I'm going to open up the 3D view. We're going to need to adjust this shape so that it really only collides with the enemies when the player is on the ground, not when they're in the air. So we need to have it kind of above the player. I'm going to mess with it a little bit to get where I want it. So the way I'm going to do this is make sure that you're out of move mode and that you're back into select mode. And we can actually just click on these orbs here. I wanted to have it right around there and then right around there. Then let's move it out like that. And I think this will be okay for now, but if not, I'll adjust it later. For sure, we do need to have this cylinder wider than the sphere. That way the player gets hit before colliding and being pushed on top of the monster's collision box. The wider the cylinder is, the more easily the player will be killed. With that out of the way, let's go ahead and click on the mob detector node and then uncheck monitorable. As it says over here, you hover over it. If true, other monitoring areas can detect this area. We don't want other areas to detect this collision shape. Then we need to go over to collision, and under layer, we need to set the mask not to the players, but to the enemy layer, as well as removing it from this first layer. Now we can set up its signal. So you can either go to the node tab or go directly to the signals tab, and where it says body entered, double click on that. We're gonna add this to the player script to connect. Then you can scroll down to where it's added it. First thing we need to do is add in a new hit signal. So I'm going to hit enter, Control Shift enter, and then type in signal hit. Then we're going to scroll down. We need to make a new function. I'm gonna hit Control Shift Enter, type in func die, parentheses, semicolon, hit dot emit, and then Q underscore free. And then for our new receiver method, highlight that, and we're just going to type in die. We're going to be using this hit signal to actually signal that we're ending the game. But first we need to connect it. So open up the main scene, then select the player node, and then in the node doc or go directly to signals, we'll see our custom hit signal right here. We're going to double click on that, and these settings are fine. We're going to use the onPlayerHit method name, hit connect. Now go to the function onPlayerHit in your main script, select that, and then we're going to get a reference to our mob timer, which we've already created. We're going to call it stop function when the player gets hit. And now we're done with being able to kill the player. We go back to the player script. This should be pretty simple to understand. So this die function is called whenever the mob detector detects that a body has entered it, which will be an enemy. So that's you getting hit. And then it will call the die function, which emits the I've been hit signal, which we'll use to end the game. And then Q free, which will destroy the player. Now let's see that in action. I'm going to hit F5, and when an enemy touches me, I should die. Good. Let's make sure that we don't die though when we're jumping on something. All right. Working. All right, at this point we pretty much have a functional game, but let's go ahead and add some things to make it a little bit nicer. I'm going to open up my 3D view, and then let's select our main node in our main scene. We're going to add a new child node. It's going to be a control node. Hit F2. We're going to call it user interface. It's going to put us in the 2D workspace. Make sure you have the user interface node selected, and we're going to add a new label node to it. So type in label and hit enter. With this label node, we're going to hit F2 immediately. We're going to call it score label. Then go into the inspector, and for the text, we're just going to set it to placeholder text. It says score 0. Now, because our text is white and our background is white, we won't be able to see it right now. Scroll down in the inspector to where it says theme overrides. You may have to click it like that, and then go to where it says colors. And for font colors, we're going to select this, click on that, and let's just change it to black. And then let's just click and drag here to move it away, the top left corner, just like that. Let's go ahead and change this font, but before that, what we're gonna do is click on the user interface node and look to the right back in the inspector to where it says theme. We're gonna click on theme, and we're gonna make a new theme resource like that. And then let's click on the theme resource to open up its settings. We need to give this a new font, and we happen to have those in the assets. So go down to the file browser, and then where it says fonts, let's open up that folder. We're going to use this one. Click and drag it and drop it right into default font. And because the default font size is too small, while we're here, let's go ahead and set this to 22 to make it a little bit bigger. Now we're going to start implementing the score feature. Go back over to the left side, and with our score label, we're going to add a script to it. Once again, this should be fine. Hit create. We don't need these, so delete those, and then type bar score is equal to 0. Now, because we need to increase the score whenever a mob is killed, we need to find a way to connect this script to the mobs so that we can use their squash signal. However, because the mobs are spawned in after the game is ran, we can't be putting references to every mob here in the code. It doesn't make sense because they don't exist. So we'll have to make the connection in code when the monsters spawn. So to do that, let's go back to the main.gd script and then go to the onMobTimer timeout function that's right here. At the bottom, after it's been spawned, make sure that you're within the function. We're going to type mob.squashed.connect, and this is going to be a little bit of typing, and it won't auto-complete for you. User interface / score label dot underscore on underscore mob underscore squashed dot bind parentheses. That's it. All this typing is one of the main reasons why I don't like to do references using this method, but I'll be going over a better method in a future video. So this line means that when the mob emits the squash signal, the score label node will receive it and call the function onMobSquashed. Let's go back to the scoreLabel.gd, and we need to define the onMobSquashed callback function. It should look like this. Type in func underscore onMobSquashed. Score is plus or equal to 1, and now the text is equal to, in parentheses, score %s score. I'll be going over format strings in more depth in a later video when I start covering the manual, but as you can see here, this %s is just a placeholder for score, so it's going to take the score variable and just pop that right in there. With this done, if we hit F5 and we start squashing, and not dying. We can see that our score will increase as long as we're okay at the game. There you go. I'm gonna hit F8 to close out. Now let's add the ability to retry the game after we lose. So make sure you have the main scene selected and select the user interface node. It's gonna put you back in the 2D workspace. And to the user interface, we're gonna add a color rect node. We're gonna name it retry. And we want it to span the whole viewport. So go over here to the anchors and we're gonna do full rect, just like that. This doesn't fill up our whole viewport because it's a child of the user interface node. It will only fill up to its parent size. So we need to click on user interface, click on the anchor presets, and we're also gonna do full rect. And as you can see, this is now filling up its parent, which fills up the viewport. But we need to make this darker. So make sure retry is selected, and then right in the inspector, very easily you can find its color. So let's select this and drop it all the way down till it's black. And this A slider here controls its transparency or its alpha channel. We're gonna select this and move it to the left. With the retry node selected, we're gonna add another child to it, and it's gonna be a label node. Let's immediately rename that to retry. Make sure you have the retry node selected, and we're gonna give it another child. Hit Control A, and type in label, and hit enter. We're gonna give it some text on the right, type in press enter to retry. Then we're gonna go to the anchor preset, and we're gonna use the center anchor. It's like that. I'm gonna press Control Alt O and type in main so we can go right to the main script. We don't have a ready function, so we will need to define it. Type in func_ready. It should autocomplete. I'll hit enter. And let's get a reference to our retry node. So $ user interface, and it is auto completing for us, thankfully. Retry.hide. What this does is when the game starts and this node is ready, it's going to automatically hide that whole UI from us. Then we go to where the player gets hit, on player hit, and let's do the same thing. I could have copy and pasted it, but this way you get to see it again. Do user interface, retry, and we're going to show it. That's it. Now what we want to have happen is when the player presses the enter key, we want the game to restart, and we're going to do that in the unhandled input method. This is built into Godot. We're going to add it here underneath the ready method. Go ahead and type in func_unhandled input. I'll hit enter. This will be a little long. You're going to type in if event dot is action pressed, autocomplete that. We're going to use UI accept and user interface /retry, autocomplete that, visible, then get tree dot reload current scene, and this will restart the game for you. It's basically just checking if you're pressing the enter key, which is what UI accept is bound to by default, and retry is visible, then reload the current scene. Make sure that works. So I'll hit F5, and on hit, I will press enter, and it restarts. Now let's add some music to our game. For that, we're going to be introducing auto loads. First thing we need to do is create a new scene. So I'm gonna hit the plus button right here, and then click on other node, and then find the audio stream player by itself, not audio stream player 3D. We're using this because the 3D one uses positional audio, and we just kind of want this to play no matter the distance the player is to something. After you've made the scene, go ahead and rename it to music player. With that, look in your file browser for house in a forest loop. We're going to click and drag that over to the stream resource spot right here. Drop it in there. And then make sure that autoplay is turned on. Then let's save this scene as music_player.tscn. Now we need to register this as an auto load. In order to do that, let's go over to project settings, and globals, and auto load will be the first tab. Click on this little folder icon right here. We need to find our music player scene. Obviously it's this one right here, but if you're having a hard time, you can just click on this to change it. So we're gonna use musicplayer.tscn and then click on the add button, just like that. What I'm going to do is I'm going to lower the volume of this so you can hear me talking, and then I'm going to save it and hit F5 to run the game. We look on the left hand side and click on remote, and this will be basically the scene tree for the currently running game. And as you can see here, here's our main scene and everything that came with it, and along with that is the music player node that has been added into the scene via the auto load. All right, we're almost done. Now we're just going to finish up the animations and we'll be done with our 3D project. Let's start by going back to the player scene. Let's select the root node for the player, and I'm going to hit Control A. We're going to add an animation player. enter. After we've made this, the animation dock will appear at the bottom. Go ahead and click on animation, and we're going to go to new. Let's name this one float. Hit OK. We want this animation to start automatically, so make sure to click on autoplay on load. We also want this to loop, so click on these animation looping arrows. And just for ease of use, let's go ahead and pin this so it doesn't go away when we start clicking around. So for the length of our animation, we're going to change this to 1.2. Now we can start doing our keyframes. Make sure that the character node itself is selected first. And under the inspector, underneath the node 3D section, click on transform. Now while we have the animation dock open, we can actually keyframe things here. And we're going to start setting a keyframe for the default position. I'm going to hit create, that's fine, as well as rotation, and then create, and that's fine. I don't really need 18 seconds of time on my line right here, so I'm going to go ahead and zoom in by clicking and dragging here and moving it right over there so I can see it all. And this way we can be a little more accurate. First thing we're going to do is we're going to move the position keyframe to 0.3 here. And then move the rotation keyframe to 0.1 right around there. Then let's move the track head or the time cursor here over to 0.5 seconds roughly. We can also use this to snap. And by this, I'm talking about this little apply snapping to timeline cursor button. So again, make sure everything's snapping. Now, because I've been clicking around, my inspector lost its focus. So let's go back to the character. And now we're going to adjust its position again. So let's set the Y position to 0.65. And the X-axis rotation to 8. Then we'll keyframe both of these. So I'll click this, and then I'll click that, and you'll see the keyframes appear right there. Then let's move to 0.7 seconds. After that, move the position keyframe to 0.7 seconds, and then move the track head to the end. We'll have to re-click on the character, and then set the Y position to 0.35 and the X rotation -9 degrees. And then make sure to keyframe both of these so you can see right here. Now it might be useful if we could actually see what we were doing. We can preview it by scrubbing through here and also hit the play button. And that's our animation. You can pause it by clicking this. This animation looks kind of linear and a little robotic, so we're gonna have to give it some curves to give it a smoother motion. So go down to your animation player and let's select both of these. And then we can play with the interpolation between these two things. You can see it gives you very different effects depending on where you click and drag the curve. If you don't like messing with things like this, you can also just right click on it and we can give it an ease out. And that gives it a nice easy curve as well. Let's go ahead and do the same thing to this second rotation keyframe. I'm going to right click. I'm just going to do ease out. And then for the very last position keyframe, I'll select it. I'm going to do ease in. So altogether, the animation should look quite a bit better. Now let's take a quick look at that in the game itself. I'm going to hit F5 after I save it. We've got a little animation going. We're a little too close to the floor, but we can fix that. I'm going to hit F8 to close out. And then I'm going to select the pivot, go to its transform, and I'll just adjust its Y position a little bit up. So I'm going to set the pivot to 1, and that should look a little bit better. Yeah, it might be a little too high, but that's okay for now. Hit F8 to close out. We can make this animation just a little bit better by controlling the speed via code. So let's get started with that. Since we're already in the player scene, let's go ahead and click on this script icon to open up the player script. And then we'll go into the physics process section. We'll look for the area where we were checking for the direction. And after all this, go ahead and type in $animationPlayer.speedScale is equal to 4. And then come out of that if statement and in line with it, we're going to do an else statement. So else, another reference to AnimationPlayer.speedScale is equal to 1. If the direction is not equal to vector 3.0, so as long as we're moving, we'll have the animation play faster. If we aren't moving, we'll have the animation play slower normally. In addition to that, we can add a nice little animation effect here by having the player arc when they're jumping. So here, let's get a reference to pivot. Go down here, .rotation.x is equal to pi divided by 6 times velocity.y divided by jump_impulse. And this whole line should actually go here at the bottom for move and slide. Make sure it's all in line. Control S and let's run the game. That's what gives us that kind of cute little arcing motion when we jump. You have to remember that Godot runs off of radians, so this pi divided by 6 is about 30 degrees. So it just gives us a little 30-degree arc as we're jumping. So because both the mobs and the player have the same pivot character structure, we can actually reuse animations between them. So let's set that up. Make sure the player scene is open and then click on the animation player. Go to animation and then manage animations. Then we're going to click on this copy button right here next to the float animation and then close the window. Now let's open up the mob scene, and with the mob node selected, hit Control A and we're going to give it an animation player. With animation player selected, go down to animation, manage animations, then click on new library. It says global library will be created. We don't need to put anything into this text field, just hit OK. Now we'll click the paste icon right here. That's our animation. Then we can close the window. Back in our animation doc, go ahead and click on the autoplay button right here and make sure that loop is set, and it is. Then let's open up the mob script right here. And at the very end of this initialize function, let's add this line. $animation player dot speed scale is equal to random speed divided by minimum speed, and this will give their speed some variation. Let's run it and make sure it all looks good. And as you can see, all the enemies have slightly varying animation speeds. And with that, our little game is done. I'm gonna hit F8 to close this. All right, now we're all done with the project. Thank you so much for watching. I hope everything went well for you. If not, if you had any issues, please leave me a comment and I will get back to you and I will help you out. In the next video, we'll be going through the manual itself. Hope to see you there. Goodbye.